Okay, let's talk about relative density, which is nothing but density of a substance upon density of water. Now, there is a bottle called as density bottle. How does it work? So what you have to do, so this is the density bottle. Okay, you fill it with water. So you have particular volume. Remove this and fill it with the liquid of which you need to find the density. For example, I have oil in it. So the liquid which I have put inside that, the volume of water and volume of liquid both will be the same. You need to find this and find the weight of the liquid. Okay. So for example, with the bottle, the weight of liquid is W2. And the weight of water plus the bottle is W3. I repeat what I have done. I have taken water, I have filled the density bottle with the water. I will find the weight. It is W3. This is water. Now, with the liquid, it is W2. So this is the liquid. Then I will remove everything and I will find the weight of only empty bottle. Say this is W1. This is empty bottle. If you want to find RD of that liquid, what you have to do? It is W2, that is liquid, minus empty bottle upon water minus empty bottle. So W2 minus W1 upon W3 minus W1. Now, it might happen that you have taken this as W3 and this as W2. So, it depends what is your W2, what is your W3. So, this is the weight of liquid plus the bottle. So, you have removed the weight of the bottle. This is water plus bottle. So, you have removed the weight of the bottle. So, you will get W2 minus W1 upon W3 minus W1. It does not have any unit. Clear? Understood? So this formula we will use to solve couple of numericals which are very important. You'll also use the same formula in higher standards. Question number 1. The weight of empty bottle is 24.5 gram. Let us take that as W1. Weight of water along with the bottle is, so I will take that as W3, 56.2 gram. And weight of the liquid along with the bottle, that is W2, it is 51.2 gram. You need to find the RD. Is question mark. I will use this formula and I will substitute. RD will be W2 minus W1. So 51.2 minus 24.5 upon W3 minus W1. So 56.2 minus 24.5. You see this? This is same. W1, W1. Now to subtract this, we will use vertical method. 51.2 minus 24.5. If you subtract, this will be 12, 7 decimal. This will be 10, this will be 4. So 6 and 2. 26.7. So this comes to 26.7. Next, 56.2 minus 24.5. This will be 12. This will be 5 decimal 1 3. 31.7. I got 31.7. Now when you divide this, we will have to divide this. So decimal, to remove decimal, you will multiply by 10. So 26.7 into 10, 31.7 into 10, 267 by 317. Now you cannot solve this. So you will have to use which method? It is called as long division method. The denominator comes outside. Numerator will go inside, 267. Now this is greater. So it will not go 0. You will put 0. It will go in 8 table. Why? Because 8 3s is 24. It is less than this, so I have put 8. 8 7s are 6, 5. This will be 3, 1, 2, 5. Okay. Now we will subtract. This is 4. This will be 6. So 3, 1. I will put 0 here. It will go in 4 ka table. Because 4 3s are 12. It is less than this. So you will get this as 8, 2. This will be 6 and 12. This will be 12. Okay, this will be 13. So 7 and 0. We'll stop here. 0.84 is your answer. It does not have any unit. Clear? Copy this. Then we will solve a similar sum to this. You can pause and copy so that you will save some time. It says that weight of water is 45 gram. Second sum, so W3 is 45 gram. Along with the density bottle. Weight of mercury, that is the liquid given, is 36 gram. You need to find relative density. Weight of empty bottle, that is W1, is 20 gram. So relative density's formula is W2 minus W1, W3 minus W1. Substitute 36 minus 20, and here it will be 20. Okay. Weight of, you need to find the value of this. So the weight of water is 45 and mercury is, it is 360. I'm sorry, this is 360. My mistake, this is 360. Now if you subtract, this is 340 upon 25. It will go in 5 table. 5 5s are. If you divide by 5, it will be 68. So let us divide 68 and 5. 5 1s are 5, 18. 3s are 15, 30.6. So this is 30. So it is 13.6. No unit. It does not have any unit. So you can just copy this. This is sum based on relative density, or you can say density bottle. Clear? Copy this. The next topic we are going to start is force and pressure, that is motion. Now what is the meaning of motion? Motion is nothing but change in position. So right now position of this pen is here. Now it is here. So I will say it has made some motion, or I can say it has changed its position. Okay. So change in position is called as motion. But it is always with respect to something. I will give a simple example. A person A, person B, and there is a person C. Both A and B are going in bus. They are moving. For person A, B is not moving, and for person B, A is not moving. But for a person C, both A and B are moving. Means what? It is a relative concept. The same person A was stationary for B. Same person A is moving for C. So it depends who is observing. So motion is a relative concept. Sometimes when we go in bus or car or train, when you are going ahead, you feel the plants, the trees, or the platform, everything is going behind. Actually, that is not true. No one is moving, only you are moving. Hence, we feel that they are going behind. That is the meaning of motion. Okay? So when there is a change in position with respect to surrounding, we say the motion has taken place. Now there are different types of motions. Let us talk about translatory motion. Translatory, then we will have circulatory we can say, oscillatory, random. Okay, so these are different types of motions. Circulatory, or you can even say rotational. Translatory, we can say linear. Oscillatory, you can even say periodic, and random motion. There are different types of motions. First, translatory. Translatory means what? When a body is moving in a straight line, we say the motion is translatory. Example, I am walking. So that is a translatory motion. Circulatory or rotational means what? When it is rotating around a fixed axis. So this is a rotational motion or circulatory. This is circular because I am going in a circular path. Example, your fan or the wheel of a car. Oscillatory. What is the meaning of oscillation? Oscillation means to and fro motion. So pendulum, simple pendulum, it makes an oscillatory motion. To and fro motion is called as oscillatory motion. Random means what? Zigzag, it is going here and there. It is called as random motion. Example, ball. I am throwing a ball. So ball is rotating. It is going here and there. So it is called as random. Now there are few examples where you have translatory as well as circulatory. The wheels of a car, they are rotating as well as moving ahead. So rotation. So rotation means what? It is rotational motion. It is going ahead. Means what? It is as well as translatory motion. Random means what? It is happening randomly without a particular pattern. So it is called as random motion. Okay. Now we will talk about two types of quantities called as scalar and vector. What is the meaning of scalar? What is the meaning of vector? Scalar means it only depends on the magnitude. Means what? Depends on the value. Vector, it depends on magnitude as well as direction. Example, if I ask you what is your mass, you will say your mass is 40 kg, 30 kg, 35 kg. So you have given only the value. You will not give the direction. Will you say, sir, my mass here is 40, there is 45, here is 35? No. Does not depend on direction. So example is mass, time, temperature, distance. What is the distance between Mumbai and Delhi? You will say, sir, 1500 kilometers. You will not give the direction. You will just give the value. So it is called as scalar quantity. What is vector? Vector is a physical quantity which has magnitude as well as direction. This is marker. I am throwing it. I am just releasing it. Where does it go? It was pulled by the earth. It was pulled by the earth. So what is the name of that phenomena? You will say, sir, it is earth's gravity. Or you will say it is due to gravitational force. So force is a vector quantity. This example, where did the earth pull? It pulled towards itself, means it went down. So gravitational force is always towards the ground, means in downward direction. Since I am giving direction means force is a vector quantity. Next example, displacement or velocity. Here you will raise speed. If I say, where did you move? You will say, sir, I went from first bench to last bench. So you gave me what? You gave the direction. So displacement is a vector quantity. So today, in this chapter, under this topic, we will talk about speed, velocity, acceleration. You have already studied speed. Speed is nothing but distance upon time. So what is velocity? Velocity is equal to displacement upon time. This is distance upon time. Velocity is displacement upon time. Okay, so we have two types of quantities, that is scalar as well as vector. Then we will talk about distance and displacement. Distance is the actual path followed by the body. What is displacement? Displacement is the shortest distance. I went from A to B, say 10 kilometers, and I came back. What is my distance? You will say 20 kilometer, because I went 10, I came back 10. But what is the shortest distance between my initial and final? Answer is 0. So I will say displacement is 0. So it is the shortest distance. We will not talk about the path. It is where did you start, where did you finish. That is what is important. It is a scalar quantity. It is a vector quantity. Distance is always added, means it is always positive. Displacement can be positive, negative or 0. How? I went from A to B, that is 10 kilometer. I took a U-turn. Right now I am here. So this is 10 kilometer. This is 2 kilometer. Right now I am at C. So what is my distance? My distance is 10 plus 2, 12. What is my displacement? It is the shortest distance between A and C. So what is the shortest distance? This is 10 minus 2, answer is 8. So my displacement is 8. So you can see it has reduced. Now if I come back to A, my distance is 10 plus 10, 20. What is my displacement? It has become 0. Right? So we saw it can be 0. Now if I move ahead, so I went here 10 kilometers. Since I went in wrong direction, distance does not get affected. It is 10 plus 10, 20 and again 10, 30. It is always positive. It is getting I'm just adding up. But displacement, I went there, I came back, it is 0. Now it is going in other direction, wrong direction. So your answer will be minus 10 kilometer. So distance, displacement, it is actual path, shortest distance, scalar, vector, always positive, can be positive, negative and 0. Okay, but both SI unit of distance and displacement is meters. So make a note of this, distance and displacement.